All right, welcome back. So let's do another problem. This will be the last problem in this section today. Doesn't mean anything to you because by now you have more videos to watch if you want. So this is number 26. Y double prime plus 2y prime plus 2y equals 4t e to the negative t cosine t. Okay, so let's do the homogeneous part first. Okay, so that means we're setting it equal to 0. Y of t equals e to the rt. Okay, and we get the polynomial r squared plus 2r plus 2 equals 0. I won't even solve that here for you. I think we all know how to do that. R equals -1 plus or minus I. Okay, so our homogeneous solution is C1 e to the negative t cosine t plus C2 e to the negative t sine of t. Okay, so now this e to the negative t cosine t is part of this, isn't it? Oh man. Okay, so that means we're going to have a particularly one of those nasty particular solution types. Okay, but we got this. Okay, so our particular solution is going to be y sub p of t is going to be, now we're looking at the form on page 178. Okay, so it's going to be t to the 1, okay, times, now we have to have all the forms, so we have this t here as well, so we're going to have at plus b e to the negative t cosine t plus t ct plus d e to the negative t sine of t. Okay, so let's take our yp prime. Let's first write that out as yp of t is at squared plus bt e to the negative t cosine t plus ct squared plus dt e to the negative t sine of t. Okay, let's take yp yp prime. Yp prime of t is going to be 2at plus b e to the negative t cosine t plus, minus at squared plus bt e to the negative t cosine t minus at squared plus bt e to the negative t sine of t. Okay, that's just the cosine, that's just the part that comes from this part. Now we got the CTs, so plus 2ct plus d e to the negative t sine of t minus ct squared plus dt e to the negative t sine of t plus ct squared plus dt e to the negative t cosine t. Okay, now I'm going to go ahead, just like I normally do, I'm going to try to put everything together. Okay, so I've got some cosine t terms. I'm going to put those together, and I'm going to put the sine t terms together. So yp prime of t equals, put the cosine t terms together first. So at squared, no other t, oh, a plus c t squared. Okay, so that's, oh, try that again. Negative a plus c t squared. So that's this negative a, that's c. Any others? Nope. T terms, 2at minus b plus d. And then the constant terms, b, looks like it. E to the negative t cosine t. Plus, let's look at the sine terms now. So the t squared. So I'm going to have minus a here, plus c here, nope, minus a here, minus c here. Okay. Okay. Plus the t terms. So the t terms are going to have minus b. Remember, these are the t terms with the sign. So minus b plus 2c minus d. And then the constant terms is just going to be plus d. Excuse me. E to the negative t sine of t. So that's yp prime. Okay, I still need yp double prime. Oh my gosh, this is a pain. Yp double prime. So that's going to be negative 2, sorry, 2 times negative a plus c plus 2a, and that's different t there, 2a minus b plus d e to the negative t cosine t. You know what? Yeah, no, never mind. I'm gonna keep going. I'm trying to quit on you guys, but no, I'm not gonna do that. Minus this whole mess. Okay, that's from the e to the negative t. Then minus it again. But now this time, the cosine changes to sine. Okay, so this first term was just taking the derivative here. The second one, the derivative of e to the negative t is minus. And the third one, the derivative of cosine is minus sine. Okay. Now for the sine part. Ugh, running out of space. Now for the sine part. So I'm going to take the derivative of this piece. So plus 2 minus a minus ct. Change the font there. Plus 2c minus b minus d e to the negative t sine t. The next term, I'm going to just copy and paste it again. This one's going to get a minus because of the e to the negative t. Derivative of sine is cosine. And there we have our yp double prime. Oof, what a menace. Okay, now we're going to solve the particular solution. Oh. Okay, so, let's see, I'm going to need to make space again. Okay, so we're going to look at, remember, this is what we're trying to solve. Let me write that down over here somewhere so I can have it. That's what we're trying to solve. Okay, so yp is here. Let me write it down, or not write it down, but that was yp prime, actually. Yp was here. And yp double prime, ooh, let's see. Let me write yp double prime down. So I'm going to try to get the pieces of yp double prime together. This is a ridiculous problem, you see, right? Okay, I gave up on it the last time I did it, so I'm not giving up on it today, not with you guys. Okay, so yp double prime. We're going to look at first the t squared cosine t terms. T squared cosine t terms, we have this and this, right? So minus a plus a minus c minus a minus c. So that's going to be minus 2c once I get it together, right? See, plus a minus a cancels, minus a c minus 2c t squared cosine of t. Oh, they all have e to the negative t. Everything is going to have e to the negative t, so I'm just going to keep that until the end. Okay, now let's look at the t squared sine of t's. This is just on yp double prime. So on yp double prime, t squared sine of t is going to be, so I've got a minus c here on t squared sine of t. Anywhere else? Oh, minus c here. And a minus c here. Or plus c there. Minus c plus c, right? Because of this minus. So there's no t squared sine of t term. But just making sure. Good. Okay, so no t squared sine of t term. That feels weird. There should be some symmetry there. Let me just double check that. I know why. There is a symmetry. Plus a plus a. So there's actually 2a. That's better. Okay. I know to look for, I haven't actually done the particular solution yet. I'm just doing the second derivative. They should look somewhat similar. So the fact when I saw this was negative 2c and I was getting 0 here, I knew there was something off, okay? But now I trust that, okay? Because, okay, 2a and a negative 2c. So there's a symmetry there, okay? Now let's look at the t terms. T terms, let's look at t cosine t first. So t cosine t is going to have, well, negative 2a. Let's see here. 2a, so the 2a's here cancel. See anywhere else? No more a's. How about the b's? Oh, that's not with there. Minus b. There's a minus b cosine t. Anywhere else? Minus b cosine t down here too. So there's minus 2b cosine t. Minus 2b t cosine t, sorry. Okay. Let's put in here. Let's take a look at c's. There's a 2ct cosine t. Minus 2, that's in sine, never mind. 2c, so there's a 2ct cosine t. None here, none here, none here. That's sine. So 4c t cosine t. Anything else? Let's say d's. Minus dt cosine t. Minus 2d, right? So there was a minus d here and a minus d here. So that's minus 2d t cosine t. Okay, still got plenty of space, although running out. How about, is that it? So the a's there were none, right? Because we had the 2a here. Just checking the 2a and the minus 2a there canceled. Okay, good. Okay, the constant terms. 2a, this is 2a times cosine t. Let's see if I've got any canceling that out. Nope. So actually, let's look at the sine terms first. The t sine terms. Okay, so t sine of t. Now, it should have some symmetry with this. It should look somewhat similar in terms of its coefficients. Okay, so, and that's really the point of why I'm doing this, so that you guys can see the way that I'm, whatever. Okay. Oh, this is ridiculous. Okay, so let's look at the t sine t terms. So t sine t, I'm going to have 2at here minus 2at there. So that cancels. Okay. Negative b, let's see, negative b, so minus 2b t sine of t. Let's take a look at the d's. I'm sorry, the c's. So we're looking at the ct sine of t term. So here, no, here, minus 2c plus 2c. So the c's cancel. So let me just double check that a's terms again. 2a minus 2at, those canceled. You know what? Okay, I'm not doing this. I'm done.